talk about space physics. So there are some things that I want you to know, that you're going to need to know. And the first one is, listen to this. You have to know this thing called 1 light year, okay? So when we say that the light has traveled 1 light year, we would want to know what distance light has traveled in a year. So we actually found it, and I want to show you the long formula, to be 9.5 times 10. Are you seeing? We can say times 10 to the 15 meters. Or we can say 1 light year, if we want it in kilometers, is 9.5 times 10 to the 12 kilometers. Remember this. This is the distance light travels in 1 year. So what you're going to have to do is you are going to be given the years that light has traveled, and you have to convert that to a distance. How? By multiplying by the distance light travels in 1 year. So if I multiply this by the number of years, I'm going to get the distance light has traveled. Okay? We need a distance for the formulas which you're going to have. Okay, because for the formulas now, which you're going to need, remember you have this, right? Just make sure you have this. You can find the distance that light travels in whatever the years they're going to give you. So if they say that something is 30,000 years away, remember you can get the distance. You're going to say 30,000 times this, okay? If you want it in kilometers, you say times 9.5 times 10 to the 12. So remember this one, 9.5 times 10 to the 12. This is going to be light year in kilometers, and 9.5 times 10 to the 15 meters is 1 light year in meters. Okay, the distance. If you want to remember it, you can say, if you have forgotten it, is this. No, let me not do that. We'll waste our time. Okay, so here we have that. Are you going to be fine? All right. Hopefully you'll keep practicing this part, right? For you to be good at the calculations. Now, what are the calculations that I need you to know? Okay. So, okay, there's one thing which you must just remember. For example, you must remember some basic formulas first to say speed is distance over time. So you may be told, because light is going to move at the same speed, so we can use this formula. This formula is only used when something is moving at the same speed. For us, light is going to be moving at the same speed. So the speed of light, we have it as 3.0 times 10 to the power 8. This is meters per second. I keep talking about it, right? All right. So sometimes you may be told that, okay, some planet is orbiting and the radius is whatever. Then they'll ask, oh, how long does it take for light to reach from the sun to this thing? So the radius is like the distance, okay? So you say distance, and then you have the speed. So you'd make time the subject, okay? Take time to the other side, speed here. So you would have time being equal to distance over speed. Okay, time is distance over speed. So you'd still get the time, the amount of time it would take for light to reach whatever. This is one thing. Now let's talk about the calculations which we use for light years, for the thing which I have given you. Now there's this thing which you just have to remember. You just have to remember it. Okay, I need you to know what we call Hubble's law. Hubble's law is just V is H0 times D. This is the only formula, right? Can you see it? V is H0 times D. Are you saying it? It's not hard. We call it Hubble's law. Okay, and this H0 is going to be a constant. You will be knowing it. We call it Hubble's constant. Okay, it is a constant. We call it Hubble's constant, and it will be 2.2 times 10 to the negative 18. And this is per second. 2.2 times 10 to the negative 18. 9.5 times 10 to the 15 is you changing the distance that light traveled. If you want to find the distance that light traveled in 1 year, we call it 1 light year. So if you're told that something is 30 light years away, how long does light take to get there? 30 years, because 30 light years is the distance, we are saying light travels for 30 years, okay? Because 1 light year is the distance light travels in a year. So anyway, we're going to have H0, and we can find our V whenever they talk about speed or some recession speed, and here we'll be having our distance. Remember how we get the distance? With the number of years multiplied by light, what 1 light year is, which is 9.5 times 10 to the 15. So if we wanted it in meters, that's what we would have. Are we together? Are you understanding this? Are you understanding this? So V is HD. V is HD, but H we call it HO, which is Hubble's constant. Remember, V is HD. Remember, V is HD. I can make H the subject by saying V over D will be equal to H0, right? Is equal to H0. Now, what I'll then do is I'll then find 1 over H0, which means I'll flip the right-hand side to be a 1 over H0, and this would be, instead of V over D, it would be D over V. So I can actually say D over V now is 1 over H0. Now, this is important because 1 over h0 is going to be the age of the universe. If you want to find the age of something, it's just 1 over h0. That's how you get the age of the universe. The universe. Okay? Which we can still say d over v. Okay? Would get the age of the universe. So 1 over h0 or d over v will still get the age of the universe. So if you ask for age of the universe, it's just 1 over h0 or d over v if you have d and v. You understand? How easy. Then remember, v is h0 times d. V is h0. So first we just gave you for what 1 light year means. Then I gave you the v is h0 over d, which is Snell's law. Then I gave you the age of the universe, which is 1 over h0. So v is h0 times d. Do not forget that. V is h0 times d. Now we have one thing, which is now the orbital speed. Let's talk about that one last thing, which is the orbital speed. Remember, we just say speed is distance over time. And the distance here now, it will be the distance of the circumference, that distance. So it will be 2 pi r, and we divide by time it takes to go around an orbit, which is period t. So this gives you the orbital speed, and you will be done. Are we fine? Are we fine? And this gives you this leads to the end of this whole thing. So now let's go and do some questions. Remember, we just need to know, let's summarize it. We know 1 light year is equal to 9.5 times 10 to the 15 meters, right? Which you say 1 light year is equal to 9.5 times 10 to the what now? Times 10 to the 12 kilometers. That's what 1 light year is, right? And then we saw that v is h0 times d, okay? This is Hubble's law. And what is our h0? Do not forget h0. It is 2.2 times 10 to the negative 18. And this is per second. 2.2 times 10 to the negative 18. 10 to the negative 18, right? 2.2 times 10 to the negative 18. So you would remember it, another one. Then now remember that 1 over h0, which is the same as d over v. This will give me the age of the universe. Age of the universe. Then I had the orbital speed, which is 2 pi r over the period, the time it takes to go around one complete revolution. And it gives me the speed that something is going around in. And I would be done, okay? Just some other basic things, but this is going to be it. 2.2 times 10 to the negative 18, 9.5 times 10 to the 15. Do not forget these ones. We need you to remember them. Because remember, this one, you're going to use it to find d. You'd get d as in, how do you get d? You multiply the number of light years by what 1 light year is in meters or in kilometers, depending on what you need it in. And you are done, okay? Now let's keep going. Let's do some questions now, and let's see how it goes.